And then you should be able to share maybe with your screen chat. Screen share. Ta-da! Okay, hopefully that works. And then you can plug into the projector. You have to stand up there.
Oh man.
Oh, but you also could play the bell if you want.
So they saw the thing where you can try to pull yourself out of the car. So this thing where they had like 3 different size metal weights to the point where if you were a bigger dinosaur, it was like exponentially harder to pull yourself out of the car because you have more surface area to do it. So you sit there as like a 6-year-old. Great power.
Oh.
Thank you for reaching out to me. I'm the guy who said, it's next month.
Yeah, I like it when you're suggesting. We can talk about any number of things.
I was floored when it came back to Destiny.
Hey, you have to calm down.
I stood you up in November.
All right.
I worked all day and I was just shattered.
Where are you talking about? So, hey, I see that.
Where are you coming from?
You're in Senegal.
All right, it seems you.
How do I share screen?
Is that what you want on the right? And then you'll have to switch to his presentation later.
I can share. I'll just share the whole thing.
You do have to have your mic on. Do you have that on?
Is there a way to tell?
I don't know. I don't have a Mac. That would be the only one.
I'm running Windows.
That's perverted. Oh, I think so.
Well, that's me.
That's getting Eric out of this. Oh, if you want beer, then over here.
How's water?
We just serve beer here. That's it. Next door.
You guys have any open visitor Wi-Fi with
Yes, if you connect to the guest, guest.
Okay, and I work right the password.
Password is
Capital B, lowercase guest.
Lowercase guest.
Is it a hidden message that you brought? No, it says Splunk guest.
Yeah, sorry.
Is it the dash guest or
No.
No, down here. It was actually up in the.
Yeah, that's what I think the password
It was on the other side of the gate.
is. That's right on the side too.
You got acquired that. You really that.
Yeah, they're in the great town office. That whole office, I think, it's the same one that shut down. They moved it to an office. What's it?
Craig Thompson. He's in Boise. His whole team got moved down from. He's been there for a while. You know, you work together at Microsoft and things. He's been with the company that's there since he left. Okay.
I'm not sure if it's picking up from this, which I'm recording video with, or what we. No, I think it's more So I think your mic must be on.
Is the mic on? Can you guys hear me?
Say that again.
Rachel, can you hear me?
No.
No?
remote. Try again.
Rachel, can you hear me?
Or
I don't even know where the mic is.
this must be really behind. I don't keep hearing my own voices.
Input,
There,
built in.
So far behind. Okay. Yeah, it's working. That's enough.
Okay.
Okay. Is everybody ready to begin? Start.
You ready to kick it off?
I think so. So welcome everybody. Thanks for coming. Sorry we're getting starting a little late. I'm Rachel Perkins. I think I've met almost everyone. Who have I not met here? I met you before. Sorry, mouthful. What's your name?
Give me a minute.
Oh, okay.
Somebody else.
Should we go around and we're going to introduce? I think we did this last time. Start to sense if you've been here before.
Tim Watkins,
And you're from.
work at MasterCard, just moved to the Bay Area, and live down in San Mateo, halfway down the peninsula here.
And what would you like to get out of a user group?
Not only ideas for some of the things that I guess leveraging other concepts for integrating with things that we're already doing to help maybe get some ideas for guiding our internal folks.
Okay, so like more things you can do.
We've got a lot of hungry lemmings, I guess, is the word. And it's a matter of setting the bridge up right and making sure people head in the right direction. So I'm hoping to hear some, maybe learning experiences from others would be a good thing to hear.
Mm-hmm. Like stuff that maybe didn't work out and don't go that way.
Right.
Yeah.
Mistakes to avoid.
That's a good.
I've met with some folks from USAA, they're a customer of yours as well, and they had a lot of good insight. So
Cool.
things like that is what I would like.
Awesome. Next.
Sasha Bitincka, I'm with NetFlow. We are a Splunk technology partner for NetFlow processing. We're here to learn what's in Splunk and the 6.2.
Cool. We did do an actual overview last time, but I'm sure. Now you're ready.
Business development and mechanics. My primary interest is understanding different architectures and deployment paradigms.
Hi, Nicholas.
Different features that are part of 6.0 that have changed how to architect Splunk. And the second is understanding what kind of dashboards people build when they're interacting with Splunk. Because we're also looking at creating our own app for Splunk. So I'm interested in understanding what kind of dashboards would be interesting.
Are you aware of our app developer contest that's going on right now?
No, I'm not.
This is the around for that anywhere. Ping me after the meeting. Okay. Yeah, so that might be of interest to you. Who's next?
And I'm Alan Williams from Autodesk. I'm just here trying to see how other people are using Splunk, just to pick up things along the way. I've been using Splunk for quite a while, so just trying to hear ideas from others.
Maybe you can share some too. You're an experienced user.
Yeah.
That's definitely welcome. And to be clear, we're very happy to have anyone who is a user of Splunk to come and talk. It doesn't have to be a Splunk employee. In fact, we're very happy to have other users speak. So consider that.
Hi, Nick.
I'm the content manager.
Or Rachel.
So you see me hovering on there.
Looks like we have a couple viewers, so hang on, folks. We're just trying to get things going here. This is Eric. Just bear with us a few more moments.
Trying to make things more searchable for everyone so people can find relevant topics and what they're actually looking for instead of asking the exact same question over and over again.
I'm Jonathan Jenkins. I'm from Groupon. I'm here to learn about Splunk and meet other people that are using it.
That's Eric. That's the actual user group leader from Horizon. Let me just put him on speakerphone. Hey Eric, you're on speakerphone. Louder. There we go.
Okay, so
Uh-huh. Yes.
is his microphone
It's
Yeah, I think we determined that it was working. We were just really behind, so we couldn't tell in real time.
Before you come.
Oh, wait, yeah, I mean, if you're watching it on YouTube while you're doing it, then I think 10 to 15 seconds.
That's probably the case. But yeah, we're just getting started, and we're going through introductions now. So.
Okay, well, we're recording, so I'll let you proceed.
Cool, thank you.
Give me a holler if you have any problems.
Thank you so much. Feel better.
All right.
Bye.
Hi, I'm Russ. I work for the web dev group at Splunk, and I mostly work on the docs.splunk.com website. And I also maintain, though I did not write very much of the giraffe. My interest here is open-ended. I'm open for nuggets. I'm looking for nuggets. It's nuggets.
I'm Chuck. I'm with Comcast, and mostly building dashboards and writing reports and running ad hoc queries for anybody who wants to know anything about the apps that you can run on the TV now. And I reached out to Rachel because I have a lot of dashboards with 7, 8, 9, 10 panels, and right now they're all very inefficiently and stupidly running based on one query per panel. And often the queries are near identical, right? And I've tried editing the XML and reading the documentation, but I'm not smart enough to figure it out.
What version are you running?
6.1, I think.
So you can help us. Cool.
We have like an hour to upgrade.
My name is Dustin. I work for StubHub. I'm a very light Splunk user, but I'm hopefully trying to position myself to become a much heavier Splunk user in my future as I disentangle myself from some other stuff.
I was trying to remember where I knew the face from. It was StubHub.
Yeah.
So I'm Richard Bro. Hey, I'm new to Splunk. I've been here since November. Head up social, so managing our social channels, whether it's LinkedIn, Facebook, or blogs. I used to be the head of social actually at StubHub for a little while. But yeah, my reason for being here is to really get to meet folks and see what people are talking about, so I can see what we're going to be talking about in our training. This is my first Splunk user meetup.
My name's Alice Fishfield. I'm the Senior Manager of Customer References at Splunk on the marketing team. I recognize some of your names because you owe me stuff. But in a good way. I was like, oh, Callan. But yeah, I'm just here to learn and get to know people as well. And also, if I may just be honest, we are looking for some people to run webinars for us right now. Like our webinars are super educational. So if anyone is like doing that stuff, like Rachel was saying, speaking or doing webinar stuff and educating other people in your local markets and such, then you welcome your voices, and we'll do all the heavy lifting and stuff together for you.
No, the late entry group was just put food in his mouth. I'm sorry. We'll come back to you in a second then.
Oh, sure. So Dritan Bitincka, I'm member of the Business Development Organization here at Splunk. Been here for about 3.5, 4 years now. My primary focus is cloud, big data, and reference architecture. So I'll be getting up there after Nick is done. So any questions you might have?
Who are you and why are you here?
Oh, my name is Alexander. You know, like this, doing Splunk for a long time, so I'll discuss some things which we use for our training environments. We don't have official Splunk yet, when we try to manage the free version and find limitations.
Cool. And then we'll get started with Nick Filippi.
Yep, Nick Filippi. I'm on the product management team here at Splunk. I own our web framework, which includes all of our different dashboard frameworks that are bundled in the package. Outside of that, I own various other pieces like alerting and licensing and a couple of other smaller things. So what I have kind of prepared for this presentation is just a couple small things, and then feel free afterwards, at the end of this presentation, or even afterwards in this session, if there's any other questions that you guys have, or things you want to see, I'm happy to share. Anything. But as far as just to touch on a couple key topics. So one is we'll very quickly walk through what does the kind of dashboard and web framework landscape look like in Splunk? What are all the different pieces that you have available, and at a very high level, when should you use each? And then kind of Rachel asked me to dive in just a couple little topics. We chose drill downs and advanced search techniques as two kind of key areas to touch on. I can go in as much depth or as little as you guys want. So that's kind of at least the overview. Starting first, so dashboard. The term dashboards in Splunk is kind of an interesting term in that it somewhat means like any user or developer created page that we serve up within the Splunk product. That's very broad, and it can be inclusive of both like user consumable dashboards as well as like configuration pages and etc. What we would like it to be is something a little bit more concrete in what you see in front of you. So really, how we would like to think about it is a collection of searches, visualizations, layout, and interactivity, all meant to kind of tell a story. So in an ideal world, this is how we would define dashboards. But as developers, we can leverage the same framework to do almost anything else within Splunk. What are the current kind of frameworks that you have available? So these are kind of the main three areas that we're actively investing engineering effort in. So those being the visual editor, so being able to provide a WYSIWYG drag and drop editor for creating panels and elements and forms and etc. in your dashboard. Moving up from that, there are certain features within our dashboarding framework that are not supported in that WYSIWYG editor, and for that you can drop into what we call simple XML or an XML-based configuration language of your dashboard itself. Yeah.
Do you mind if people ask questions?
Yeah, absolutely.
Okay.
Absolutely. Yeah. So sorry. Feel free at any point. Pause me. Ask me questions. Ask me if you want me to dive a little bit deeper into any of these. Up from simple XML, so if there's anything beyond the capabilities and the feature set that we offer within our configuration language, we also allow you as app developers to kind of convert that directly to HTML and JavaScript. So all of our components, whether they be the charts, the layout, the form inputs that you see in dashboards, they all have corresponding JavaScript components. So we call it something. We call it a Splunk JS, and if you ever were to view source on the page, or we now, as of Splunk 6.0 even, you can convert it to HTML, and that gives you some of the raw power of editing the layout, the interactivity. You can integrate other components into your dashboard itself. But with that, you kind of lose some of the capabilities that we have in our other frameworks. Just kind of as a note here, so even though we have 3 different frameworks that allow you to build dashboards, they're very much meant to be a kind of progressive. So as you kind of move up, you can start very simply in our WYSIWYG editor. As you grow out of that, you can move up to simple and up to HTML. So it doesn't require that you choose one right off the bat. And just as kind of a note, actually going back, one thing that you won't notice here, there are some legacy frameworks that are still supported but not really actively developed on. What I refer to specifically is advanced XML. This is a framework that's been in the product for quite some time. While you still could build a dashboard using that, it's not really recommended. And if you look at some of the feature sets that we've come out with in the last couple of releases, as well as what we continue to build on in the future, there's not a lot of active development in those areas. So much so that as of actually a good segue, when we really started to invest in simple XML about a year ago, the table was kind of turned in terms of what dashboards we saw out in the wild. Since that time, since we released Splunk 6.0, with a huge investment in some of the feature sets in Simple XML. 1 year later, we're no longer even seeing a lot of developers to build in that old framework. And that's a great sign. So we've invested in the right areas. We've focused on a lot of the common use cases that we see from customers and from you guys. And we feel pretty strongly that we're moving in the right direction. So let's kind of dive into the first key topic, which is drill downs. So drill downs are in my mind, kind of one of those very powerful tools that's relatively easy to configure. And I say relative, meaning that there's certainly more complex things that could really wow end users. But drill down is one of those features where it really allows you to create a custom experience and workflow within the apps that you build. So, just to kind of list off a couple of the key benefits. One is, by controlling the user click event, in tables or charts that you build, it allows you to make additional context around that more easily available. So people can click to see more information rather than have to learn like the search language, as an example. Second, it allows you to control the format and the presentation of data. So the less you can expose your end users to the search interface, that's kind of just less questions that you're going to have at the end of the day. And second, I think it in general reduces the barrier to entry for app usage. So you have end users, you show them a new app in a workflow, they can kind of drill into the specific areas that they need to. Looking at what are the different types of drill down we support in the product, so we think of it in terms of 3 different types, and we'll walk through these in more detail. I'll even show a demo of how you can kind of build up and through these different types of drill downs. Number 1 is the default, what we call auto drill down. This is a very basic open and search. You guys are already well familiar with this. There's not much configuration to it. We use something under the covers called intentions, which we attempt to figure out what events you're trying to search for, and we pass that along in the URL to the search interface. Moving up from that, we support something that we call dynamic drill down. This allows you to link a click event to another dashboard or a website, and we'll walk through that in more detail. Number 3, which we just started support for in 6.1 in Simple XML, called contextual drill down. This allows you to click on a cell in a table or a chart and actually open up another viz in that same page. So we'll walk through how that works. Very quickly, default auto drill down opens in search. You've all seen this. There's not much to the configuration itself. It's all via the viz editor. You'll see it as you open up the little picker. You have a couple options based on the viz type, but ultimately the behavior that you're creating with this default drill down is opening events in search. Moving on, dynamic drill down. So this is where you start to link dashboards together. And in addition to linking dashboards together, you're wanting to pass certain parameters or parts of what the user is clicking on into the next page. And we'll walk through how that works and some of the options that you have in that. Some of the background concepts that we'll walk through is, the notion of tokens. So that's what information do you have available to pass on, and then what is immediately available from the user itself. Some examples of what you can build with dynamic drill down is, you can kind of see it under the examples. So you can redirect to another dashboard. You can, instead of redirecting, you can open it up in a new tab in the user's browser. You can even, within the table viz, you can pass on hidden parameters too, which is kind of a unique use case. Or you can define kind of per column click behavior. So I want, if a user clicks on a cell within this kind of column of the table, I want it to do X, versus column 2, I want it to do Y. before we actually walk through a demo of it, kind of some background concepts that are important to know. The first is tokens. Has anyone here kind of worked with tokens within dashboards? You guys all fairly familiar with it? No? So if you've ever seen, and we'll look at an example of what it looks like, tokens are used for a couple different things, most notably for form inputs. So if you've ever seen a dashboard that has like a drop-down, for example, so that drop-down, what we were effectively doing is setting a token variable that's then used in a search within a pie chart or a table or what have you. When we actually open up the XML configuration, it'll be given the syntax, dollar token dollar. You'll see that, and we'll see the interactivity within it. Why it's important for drill down is that's actually what we use to construct the URL for how we're redirecting to users. And we'll go into some of the specifics in the demo itself. So the second piece of background information that's relevant here is around user click information. So this is what do we have available from what the user clicks on to pass on to the next dashboard. So given an example of a table here, right? Let's say if the user clicks on this one particular cell in a table, what do we have available to pass on? And I'll show you this in the demo, but this is kind of a single picture to show you, what if I want, as part of that target URL, I want to include, let's say, the first cell value of that row. What if I want the column header name as well as the value? These are all kind of tokens that we set or are available to you as you click on the URL. So enough slides. Let's actually walk through an example of building. So here I just have a plain dashboard with one table, and I haven't done anything special with it. We can even see what the search is. So it's just a very simple. Do I need to make this bigger? Okay. So very simple search. I haven't configured anything other than the default drill down. So this is set to cell. Again, my options with default drill down are pretty basic. I can say row, cell, or none. The difference between row and cell is what we actually pass on to search. So to show you what actually happens, let's say I click on this cell. It's going to open in search. It's going to take my base search, which was the index, and then what I actually clicked on itself. So this is the first column, or the first field and value, and then what I actually clicked on. So now if I want to now kind of progress through those different options, let's say now I want to link this to another dashboard that I have. And specifically what I have prepared here is just a very simple form-based dashboard. So you can kind of see some of the inputs here. So I have a kind of an event viewer that's a table, and I can search on source type, and host. So going back to my original dashboard, what I kind of want is when I click on Event Gen 3 as a source type, I want to actually take the user to that target dashboard and populate this value in that target. The first thing that I'm going to do is, let's say I don't really understand that whole click value to and all the tokens that get set. I'm actually going to cheat a little bit and use an example that we published as part of an app. Are you guys all familiar with this Splunk 6x Dashboard Examples app? Is anyone not? Okay. So if you go to apps.splunk.com, I'm a little bit biased towards this app because it was our team that built it. I didn't build it. I can't. I would love to take the credit for it, but
no one's gonna know. This isn't being recorded.
displays for anyone who expose the application and get some much payment. Is it correct? Or you can
monetize on. You're talking about whether you can sell apps on Splunk.
because I looked at some applications require some license, or they're like money.
You can choose the license. You can choose whether you want it monetized. And some of them are published by Splunk and some are published by others. Yeah.
But just one place for the
Yeah. That's correct.
So if you haven't already, I would highly recommend downloading and installing this and rating this app too. No, it's a great app. The intention or goal with building this app was really to provide kind of a cookbook of examples for what types of dashboards you can create, behaviors, etc., to jump back into what it actually looks like. So once you've installed it, this is the homepage of that app. It gives you various examples of kind of different visualizations, what are some of the options within those. In addition, you can kind of see with every example that we provide, we have little tags that denote the compatibility. So this example or a recipe will work with 6.0, 6.1, and 6.2. You can kind of see others that are a little bit more selective. In addition to that, you can see other tags. This one in particular refers to if you're comfortable with JavaScript and CSS, we allow within dashboards you to load your own custom JavaScript and CSS onto the page. So this is, if you have that expertise, this shows you an example for how to extend it. So a common one is something like, table cell highlighting. If I want to color a cell within my table based on the value, this walks you through how to do it. So below every example, we show you all the source code that went into it. So in this particular case, here's the XML. So here's what we recognize as the dashboard itself. You can see as part of this extension, we load some custom JavaScript and a custom CSS file. I can go into detail as to where that's located, but if you download this app, hopefully it'll walk you through exactly how it was set up. And then it gives you the snippets for how we set it up. But by no means would I expect everyone right off the bat to kind of jump straight into this. So for those cases, we give you examples, and this is another one just to highlight before I jump into the drill down. If you want to add a simple sparkline to your tables, for example, this walks you through like all the different kinds of sparklines. And then within the actual code itself, you can find like where we do things like set the color and make this an area, where we make this a column or a bar chart, and then we set the height. Scrolling down, different types of searches, walks you through all the different types of form inputs that you can add to your dashboard, all the different drill down types, layouts, visualizations. But what we're going to focus on here is a tool that we built, and this is a brand new tool. So I think it's version 3 of this app. So if you haven't already upgraded, definitely upgrade. Part of the upgrade will feature something that we call kind of a token viewer. So what this does, once you load this custom JavaScript, and what it'll show is it basically prints out this snippet from here below, and it tells you what tokens you have on the page and what their values are. So let's say, for example, I build this line chart, and I click on this. It now itemizes, okay, you have all these variables at your disposal available to you in that URL construct. So I'm going to go ahead and go back how I actually find this. So I'm going to go ahead and edit source, and I'm going to grab this because I actually want to load this JavaScript into the page that I'm building. Go back, and I'm going to use a little shortcut. So we have so what I just did there is within within this configuration language, we allow you to load JavaScript that's part of an app package, or you can load a JavaScript that's part of another app package that's installed on your instance. So I kind of gave it a path to what app and then what file. So I'm going to go ahead and load that. And you can see that it just loaded. I wonder why it's not showing anything. Hopefully I did it okay. Okay, there we go. So back to that example where I'm now trying to kind of control the behavior of when the user clicks on this cell. Now I can look down and I could say I want to pass the name of the column that the user clicked on and the value of it. So in this case, yep, this is the name of the column, so I know click.name2, that's my token variable, and this is the value, so click value 2. Okay, so going back here, this is where I want the user to land on, right? So I'm going to steal the name of this. This is my target name. So now I'm going to go in here into the source, and so within a row, within a panel, this is the table that I'm working in. So I just need to make sure that this drill down is defined in the table itself. And I want it to be a link. One kind of tip is I always like to encapsulate my URL in a CData. This allows me to not have to escape. So if I enumerate a number of kind of tokens that I pass forward, this allows me to do it in a much more kind of user editable and readable fashion. So this is the target that we want users to land to, and now I define what variables I pass to it. So in that particular case, just off the top, so it was click.name2 equals click.value2. Okay, I'm going to go ahead and remove this. I think I got it. And now let's test it. So here, I clicked on that. You can see that it redirected me to the target page, and it passed the token successfully in the URL. So I can see that it now populated this field, and it now filters those search results based on that input. Just to kind of give you a look at what the underpinnings of this dashboard are, there's a couple things that I did. So one thing is I'm passing this. This is the token name that I passed in via the URL. I just need to make sure that it matches up with this form input. So if I go ahead and edit it, that token name should match how I pass it into the URL. So that's kind of one secret that's part of this. Then the second is, now that I've both set the token within this form input, successfully passed it in, I want to make sure that the search that's driving this table successfully uses that or consumes it. So how I made that work is in the actual search itself, I say this is what we're looking at. It doesn't really need to have that pipe S. So this is how I passed it in. So the search that's driving that table has index equals internal, and it's using whatever is getting set by that form input. Yep.
What is the type S and the other token filters? There's an H and a U.
Yeah, good question. So so that's a little bit of an advanced feature. We call it token filters. So what it actually does, so pipe S is called search escaping. So what that does is it automatically puts quotes around the value of it. And if there are any quotes in the actual value of the token, it'll escape those. So let's walk through an example. So let's say the value is like a sentence or a phrase. So the sentence is like, this is an error. That was a message, right? So the form input that we're supporting is a message, and it could have spaces in it, right? But what you actually want in your search string is, okay, so this is the value. You want the search to look like this. You want the end result to look like that, right? So how you actually do it, there's kind of a couple different ways. In my search language, I could say something, dollar message dollar. So you would do that.
Yeah, but then you don't get the escaping.
The bad thing about it is, what happens if your message looks like that, right? Then it closes it and it gets all, it doesn't handle it favorably. So what you actually want to be doing is, without error. So yeah, so you can use, so you can do this search escaping, and that's going to take care of it for you. So when it actually gets passed to the back end as a search, it's going to look something like this, whatever. It's gonna handle it for you. So it's not a well-documented feature, but now you know. You're among the few. What's that?
It gets the pipe S at the end. So.
Yeah. So this is.
And what is the H and the U do?
So there's a URL escaping and an HTML escaping. Yeah.
When did this happen? Can I use them all together? Can I type S at U?
I don't think so.
STFU.
You just type S.
Yeah, pipe S does it stands for search escaping. Okay. All right, we'll go ahead and cancel that. Okay, so now let's go back. So what we've done there is we've successfully been able to link two pages together. So now what we're going to do is we're going to start to define different behaviors for each column that I click on. So if the user clicks on source type here, I want it to go to that other dashboard. But if the user clicks on source, I actually want it to stay within the page and do something else. So there's a couple things that we'll do to support this. There's kind of two different ways, both landing at the same location. I'll go ahead and create. So in that second case where a user clicks on source, I want it to show maybe a little, let's say a line chart, like a time chart of this particular source over time. So I'm going to go ahead and add the panel first, add a line chart. I'm going to say kind of source events over time for source equals, and remember we're gonna set this token in oops. We're gonna set this in our configuration. So index equals internal, source equals $source, $, and then just do a time chart. Whoop, yep, good call. So I added that. Obviously, it's waiting for the input because that token's not set yet, right? We haven't yet configured it. And now we're going to drop into the source. Now we're starting to highlight some of the kind of advanced capabilities of it. So again, our first step was now we want to kind of define a specific behavior for this column, which is different than the other. So we're going to add something called a condition, and the link we still want that source type column to link out. But we want a second condition for that field source to do something completely different. We want it to actually set a token that will consume on the page itself. That token is going to be called source. We want to give it the value, click that value to. Oops. Okay, and that's set it. Okay, perfect. Let's go ahead and save it now and test it. Okay, so if I click on this, nice. So it now populates the title of that element with what I just clicked on, and it ran the search. So I can even look at, like, let's see, scheduler.log. Gives me that. But now the second thing that I want to add is I don't want to have to show, so going back to, so if I refresh this page, and I wait for it to load, I don't want to see this panel unless a user clicks on it, right? I want to basically hide it until this token gets set. How I actually do that, going back into the source, is we use a feature called depends. So in this chart, so this is that chart that we created below the table. I use depends equals $source $. What this says is only make this visible, only show this chart if this token is set. And I can comma separate multiple, but this is kind of a basic look. I also want it to show directly below the table. So what I'm going to use to do that, I'm going to remove the whole panel and bar and border. Go ahead and clear that. So now all I see is this table, and as soon as the user clicks on EventGen log, it then just showed the chart directly below.
Can I see the source code again?
Yeah. Let's do one. Okay, so what I have is the table. Within the table, I have a drill down element. And then because I wanted to set different behaviors for each column, that's why I use this condition, so that here I can even, sorry, a little bit. So link out for if someone clicks on this column, and if someone clicks on the source column, I set this token, and then I react to that token. If another kind of quick little trick here in the link, I can say if I don't want it to kind of redirect users, I can have it open in a blank tab. So this is kind of following the same like HTML link notation. So yeah, so if user clicks on this, it opens a new tab with that target. If they click on this, it shows it below. I have a little walkthrough on how you do some of these things, so I don't know if we're passing the material on. Perfect. So that's it for drill down. Any questions? Yeah.
So like when I was like download application rules, maybe some internals, it's kind of based on users or like with some home application.
The location of this dashboard or the location of like the JavaScript?
Pretty much location of dashboard and JavaScript. And you mentioned like about also pretty much reference to application.
Yep.
Application.
Sure.
Like it's not always good thing, but so it's like some advice.
Sure. Let's it's probably gonna be, yeah, that should be fine. Okay. So within Etsy apps, you have all of your app packages, right? And so let's take an example like, oh, do I even have? Nope, sorry, let me find another, yeah. Okay, so under Etsy apps is all of your app packages that you've installed. This simple XML examples was that first app that I showed you. It was this guy as the example. So the reason why I'm showing you this is it has those JavaScript files. It has a bunch of other things in it. So if I go ahead and CD into the app package, the structure of it, so we have the typical default and local. So where the dashboard, that XML, you know, when we were seeing the source of the dashboard file itself, that resides in defaults, data, UI, views, and this shows you all of the XML files that we have. So these are all these are where the dashboards reside. If I go up, yeah, I mean there are some exceptions, right? If you edit this, it'll reside in local. If you make it a private dashboard, it'll reside in your users directory in this path. So there's 3 places that a dashboard XML could reside. So walking through an example, if you go to apps.splunk.com, you download an app, you install it on your instance. All of those, so the default dashboards that come with that app, they're all going to reside in defaults. But let's say you as a user, you look at one of the dashboards that comes with the Unix app as an example, and you want to edit it. You want to remove a panel, right? You can click Edit. You can delete one of the panels and then save it. That save, now you've forked a copy of that dashboard and you put that new XML in local. The old one will stay in default. So yeah. Then let's say additionally you want to make that private. It'll get moved to your user space, so it won't. So other users that log into the system won't actually see the changes that you made.
Let's say, for example, the Splunk version where you have no user management. In this case, it will go to local.
Yep. So it'll just go in the local. Yep.
So if you want to manage your changes, maybe with some source control, you actually need to. What is the best place to start with? Like, at which level?
So for any type of like source control management, if you're, let's say you have a UAT environment and you're building an app, once you've actually built that app, you'll most likely move all of those local dashboard files into default, package that full app package, and distribute that. So the structure for that will look similar to what you would see in an app that you would download. I don't know if that answered your question.
still be under default also?
Correct. Correct.
And pretty much you have all applications here. So a little confused because you have your application which has maybe like 5 dashboards. So here you have all of them. And for me, it would be logical if you have your maybe one directory which with only dashboards for your application. So it's not working this way.
Well, so for how you would deploy, it would all be in one directory. It would be in the default directory.
But if you have one application, all will get will keep dashboards here. Is it correct? Is my understanding?
No, so each app has its own default.
Oh, each app.
Each app has a default local
Okay.
Because so we make sure that
Yeah.
single XML examples. That's one aspect. So if you go out one level, you've got a whole list of apps. So each of them has local default. Okay.
How are we doing on time, Rachel?
Let's see, take another 10 minutes to get started up.
Okay. Yeah, so if you have other questions around drill down, feel free to grab me later. The next kind of topic that I want to talk about is search techniques. So just as a kind of heads up, all that I'm going to be talking about here is specific to Splunk 6.2. So I'm going to very quickly kind of introduce you to the new search syntax, specifically the XML piece of the search syntax in 6.2. I think you guys are going to like it. It cleaned things up a significant amount. And then second, we'll walk through a little demo of how you actually build. I think your use case was 14 different panels that all look and feel the same, and how do you kind of link and leverage as few searches as possible. Wow, I don't know why that doesn't look right. So to introduce you to the new search syntax, let me.
It loves this slide.
It loves this slide. Okay, so this is this shows a little bit better. So we completely kind of collapsed and reworked how search managers kind of get defined in our dashboards in 6.2. Specifically, you guys probably all banged your head against the wall when you had to learn what search templates were, and search strings, and search post-process, and the whole nuance within this. So what we've done in 6.2 is we've kind of across the board normalized everything, and this is kind of what we came up with. Here's a link to our docs to walk you through it. But there's a couple concepts as you start to define a search. And here's what a search now looks like. So within a given table, within a chart, even within a panel, if you want to just instantiate a search, this is kind of what it looks like. So you have a search object. You give it an ID if you want some downstream, if you want some post-processing to be done on that search. So that's kind of a reference ID that you would give it. That's specific to that page. You define the query, and then the time bounds, what the earliest and latest is. So this could be derived from kind of your explicit search or a time range picker, what have you. These are all the attributes and kind of sub-child elements of a search object. How you actually leverage a search post-process is used as base, and you refer to that to the global search. And then if you use a save search, you use something called a ref. So ref is an external reference, and this is the name of the save search that you've created. All good so far? I'll go through an example that actually highlights what this all looks like. As far as different use cases that you can now use in this new search manager, so we made sure that all of the existing use cases were supported. Hopefully the projector is. Oh, okay, we're good here. So these are all the different types of searches that can exist in a dashboard. I can have just an inline search, very basic inline search, driving a single visualization. I can have a report-based search that's using the time range of the search itself. I can override that search. I can have a search populate form inputs. I could use a save search to populate inputs, kind of same but subtle change. In 6.1, I could have a single global search, and that could drive several visualizations. But in updating the search syntax, we now enable a couple of additional ones. So now, as of 6.2, you're able to have multiple global background searches, and then in your dashboard itself, kind of explicitly reference each. You now have the ability to do that within form inputs as well. Let's show you what that looks like. I think I have. So here's an example dashboard that I created. We used a data set from the San Francisco Health Department for inspections. There's no names, there's no dates. So I built a panel here, and the statistics that I wanted to show were kind of the breakdown of violation types by neighborhood, right? So for each neighborhood, what were the top offenders, and what are the different types? Because I was kind of hoping that some of these, all of the risks were like low risks, but unfortunately that wasn't the case. Okay, so what I have is by neighborhood, and I have a split by violation category. But then at the top, I kind of want to sum up the total of high, moderate, and low. So this kind of is hopefully similar to your use case, where all of these metrics are related, right? And I don't want to have to kick off 4 different searches in order to get this panel.
That's what I'm doing. It works.
Yeah. Okay, so let's look at what this looks like. We'll clean this up a little bit so it's a little bit easier to read. Okay. So I have a dashboard. The dashboard has a title. I have a row. I have a panel. I have a title in that panel. Here's where it starts to get interesting. Within the panel, I could have this in the panel. I could have this anywhere in the XML itself. I define a search object, right? And I give it an ID. So this represents this query, and the query is looking for. I broaden the actual query itself, so that includes kind of everything that I need. So then I start to dive into that first single value element that I had on the page, right? And that highlighted, that was looking at the high-risk violations. So in the search object of that single value, I want to grab the results of this global search, and I want to do a post-process query on it. So grab the results of that of this guy up here, and then run this query on the search results.
So in the vernacular, can you scroll back up again?
Yep.
In the vernacular of 6.1 speak, is this a search template tag, and that's a search post-process search tag?
Yeah, exactly.
Thanks.
But as in 6.1, that search template had to be at the top of the page, and yeah, and you can only define one search template. Here, I can actually define 10 if I wanted to, and then have all different references. Same guy for the second single value. Same for this third one, and even same goes for the chart, right? I'm still referencing that top search that I ran and the search results within it. I just have a little bit different post-process query on it, and that's it.
I think you unwittingly just told me what's been tripping me up when you just pretty casually said, "Oh, the search template has to be here."
Yeah, so it has to be right here. It would have had to. This is no longer. We still support it, so like we won't break your current dashboards, but
They don't work.
Might as well upgrade.
Yeah.
Hey, can I post-process a save search?
Yes. The way you would do it is, great question. So you define a search object, you give it an ID of like my save search, and then you reference it. So reference is like, so this is like search name. So now this is created. So now this is running a safe search that I have defined. Now it's also giving me an ID, a handle, for me to, let's say, I create a new single value. Same syntax applies. Just now base, I grab this guy, and I use that as my base.
How does this affect your concurrent search limitations?
Oh, great question.
At best, set them all into some kind of a serial query.
Yep. So even though we're doing a post-process query, it still is a search in Splunk terms.
It is
so
using the results from the first search that was found, but it counts against it.
Right. But it'll serialize it in that it'll run the base search, and then post-process searching will be done after. So.
Unless your users have a higher amount of concurrent search.
Yeah, it's a great question. So it performs better if, let's say, your base search is, let's say, extremely long or slow, and like so, let's say if this search took, let's say, 10 seconds to run. So if I had to run 4 different searches all kicking off, that is more expensive than if I did a single 10-second search, and these are all in the millisecond range. There's also some nuances around, let's say, going back here, if I add a bunch of, let's say, drop downs and allow users to kind of say, well, I only want to look at high-risk violations, or I only want to look at like Chinese restaurants or Italian restaurants. What you could actually do in that case is run that large query over the entire data set, return the results, and then in the post-process part, that's where you do that token substitution. So you're doing that, restaurant type equals Italian already on prefetched searches. So that's another way you can optimize performance. Ultimately, I wish there was like a more prescriptive recipe for like, hey, if you wanna optimize your queries, here's how to do it. But it really is, there's kind of an art to it, as Dritan can attest.
Yeah, I mean, it's certainly post-processing is certainly a lot lighter on the search end than having dispatch of a search per each panel or per single panel. Because you reuse it. So instead of restarting the whole search process machinery, right? You're creating connections.
Well, it's always going to be faster if you're using filter data. So if you're using smaller
But you're operating on a nicely, like a really nice and small data set that just go out to the indexers, pick up all the data, do the filtering, source typing, all field extractions from scratch.
So is it still in that architecture-wise? Is it still always in the near future plan to any single search is occupying the entire core for the duration of the search?
No, that has never been true. Oh, we can talk about that. So it's used as a rule of thumb for sizing guidance, but there are searches that are CPU bound that will occupy for the higher duration. But there are searches that not see.
So like mixes the threads or something?
Oh no, so you can have searches that aren't completely IO bound. Like rare searches, you can have a 24 core indexer that can run 60 concurrent IO bound searches, or 24 concurrent.
That information isn't well shared by your on-site.
You're right. It's not in for a reason, right? Because there are a lot of caveats that apply to it. So you never have an environment where your workload is very well defined. Typically, your workloads are very defined.
Yeah, so you've got a variety.
Like
and it's fancy grid, I'm sure.
You've got.
I'm only gonna have sparse searches for this case.
You've got concurrent users that are free to run any sort of searches there.
It just makes it very tricky to plan as an architect.
Sure.
As an architect, to plan your environment.
And that's why we say on average is 1 search, right? What makes it even more complex is that in our search language we allow users to have sub-searches. So you can have a search that can dispatch, while it's running, it can dispatch 4 or 5 other searches. The profiles of which I'm not. Those searches on their own can be dense or very sparse. They have no work. And then the whole thing as a whole can have a very combined profile.
There ever was a sub-Splunk users group dedicated to just concepts of searches and that thread, if you will?
Mm-hmm. Sure, and also you could definitely ask if you have specific questions about this. You can ask on answers.
Yeah, there's a lot of good data out there, but I think there's always mismatch of what's out there versus what's said from the Splunk employee that's on your site doing implementation from your professional services team. Yeah. So you take that word as gold, and what's there is like, oh, somebody wrote that.
We're never going to be like everyone always knows everything.
Right.
It's always going to be a problem as the company gets bigger. So it's good to know that that's confusing. That's also, since there's documentation about aspects of this, there's a field at the bottom of the document. Every documentation topic has a field where you can say, I need more information about, was this helpful, I think is what it says.
Yeah.
The team is very, very dedicated to reviewing those and responding to those. So if there's specific info that you think could be clarified, or you need more info, definitely use that field. I recommend you'll get a result.
Sort of deviate on that, but it was, as soon as I started seeing all the searches, as an administrator, you know that you limit.
Yeah.
In our case, we don't have an unlimited amount of infrastructure to serve up the Splunk search heads. So.
Yeah.
It's hard.
Is there any limitation on how many searches you can execute based on license?
No, it's only based on hardware and configuration.
Okay, so if you have like a lot of hardware, like resources, you can match it up to scale.
Yeah.
So another good question was actually you mentioned about safe search, and I remember trying to figure out, and I remember was some statement that this was kind of made to macros in some versions. So like this could have macros and safe search at the same time. Like what's the difference?
Oh, macros?
Macros?
Macros are things you use within a search.
You can say a search that has that.
My understanding is what I have to create macros pretty much, and then use it. So, and it was not called a safe search. That's
so you could use macros within a search query itself. You can also have a safe search that has a macro or n macros in it.
So what is the key difference between
A macro lets you have macro works like a function. It lets you pass parameters.
Yes, but it's pretty much my mistake. It can play same role as search itself as safe search. Correct?
You could use a macro as a safe search. It would be cumbersome.
Okay,
because
but then like why is doing another like abstraction of safe search?
So yeah, so like one macros are kind of like sub-functions within a search, so we don't have the same type of like user management or object management for macros. It's kind of an advanced knowledge object, so you're gonna have to go into manager to manage them. Second, it doesn't have the same type of like scheduling as one example, and alerting and things of that sort.
You could have designed
I mean,
a system to do both in one, but I think it would confuse.
Okay, so those are the visual features which comes with safe search.
Yeah.
Think of it as a string substitution, right? So if you want to repeat a certain, so if you have option searches that have the same common strings, right, you can use that as a macro, and then, like you said, you can pass parameters to it. You can pass variables so that you can make your XML more built up.
And then event types are just like macros without substitution. So you have all these different things. It's sort of intended to give you smaller, reusable building blocks.
An interesting thing when I was clicking pretty much on the diagram, it always was expanding this macro. Is there any setting to say not expand macro?
Yeah.
So doing somebody think about it? Let's say I have my dashboard and have diagram like based on some macros. And if I click there, like it goes to this default view with like search string and expands all macros there. Sometimes not very convenient. So we have option kind of to enable or disable extending of macros.
We don't currently. Yeah, because the intention, like how we actually derive that drill down string is we have to use the base search, and unfortunately, like how the backend dispatches the search is we expand the macros prior. So there's a lot of complexity to it.
It's very complicated. So if you assume you have a search and you have a sub search that has a macro, right? Or you have a macro that has a sub search or vice versa, whatever. When that thing resolves, it needs to run a search. Right? So the expansion may not be immediate. Right? Something like, oh, I'm gonna have to go out there, run the search, get the results of it, then populate what the macro was initially populated. So, but we do have, so if you look at the search log, search.log, expand, this view will actually show you what, actually another search debug lines will actually show you what the macro has been expanded. You can also get it out of the REST, if it's a safe search, you can do a REST call. You can do that, qualified search. Yes, so search parsing, it's a bit, I don't want to say it's straightforward. It can be complex, especially if you have recursion, especially if you have sub searches in.
Sounds like we need to have another meeting just to talk about this kind of stuff. We can do that in the future.
In my sub searches, I'm always bumping up against the 60-second 10,000 row limits. Did I sneak around those limits by using a macro? By saving macros or some time we use sub searches?
No,
I don't.
It's a sub search you want.
Even if it's a macro, it's still.
Yeah, the macro will just expand.
That's I figured.
Search gets expanded. Yeah.
Cool.
Your slides are up, I guess.
Yeah. Thank you guys.
You guys need a couple minutes to hit the restroom or get another beer?
Yeah.
All right. Yeah. Let's meet back at 5 after.
Nick, any other suggestions? I haven't just some stupid, simple syntax putting some tab in.
I know we're good.
Yeah, I did similar. No, it's from here.
Well, yeah, I do.
Okay. I got a question for you.
Oh, yeah. I can give you that.
Thank you.
Yeah, so yeah, there was some like links highlighted.
So that's enough.
Yeah.
You have a problem. I'm at 148.
I'm looking for the holes, you know, this needs to be great wire.
Computer code, that's how they used to do it like in the old days.
What do you actually see?
Big IPs are fine for a lot of people.
It sounds like it's in the world of big superheroes.
Okay.
Yeah, it might not have a search to it.
Okay.
Yeah, it's really gonna all of a sudden.
Got it.
Those are the ones who take us out.
I figured every now and
Left the hands of from all the ones.
So you said you have a key form, so that's gonna, when you load the page, it's gonna automatically, so it's a star, it's gonna resolve all the minutes.
UK artifacts.
Oh, yeah.
We edited it.
There's another
So right now,
yeah. Right, exactly.
Being my head in small project mining work. One good actually has the opportunity to say
Do you work in the city or in the town? Okay.
So what you could do is like exactly the same syntax, but and one process, see that.
Enthusiastic. Are you redlining?
Yeah.
Should be, you know, 36, yeah. Yeah, please.
every little team has
Oh, wait.
Might be a PowerPoint.
Bye. Yeah.
Actually, no, it's a really nice. I'm not customer facing, so other than every time I'm at a.
All your questions answered?
I think so.
It's like, oh, but there was a power cable that was missing one. Like the snap it. No, like so. No.
Like, let's go again. That's all right. We got another minute.
Yeah.
I told him we would probably, I told Eric we'd probably wrap up at 8:45. Okay. So, you know, we can always hang out and do something. Then you're we're just waiting for a power cord and then we'll get started.
Are you talking next? I'm gonna run out. I want to understand what we're talking about in our way. Go ahead.
Are you steal a hat?
Nick is the only one not here. So
He had the opportunity. He didn't have to load it.
We'll pull it out there.
Yeah.
Give me the motor.
I should. I just haven't had time to like find it or so while this
Just quick, do it before you forget.
I will probably look some slots.
Yeah.
And
you should also get that app.
Yeah, that's also great. I really hate to like it. Dashboard. Have a safe drive home.
They did something unique for installing 2 and 3 indexers for physical hosts.
Is he going, like, where's he going, to the East Bay?
well, I mean, we can start.
Yeah,
I've got. I mean, there's a few percent hours. All right, guys. So let's get started.
Get on to Dritan.
Yep. All right. There's a whole bunch of slides here, guys. So just bear with me. There's like 40 slides or so. So this presentation was actually given on last.conf, so it's actually available on our website. So basically all of it. Okay, just a couple of words about me. I'm a member of the Solutions Architecture here at Splunk under the Business Development team. Couple of specialties, large-scale deployments, and cloud and big data. And cloud, I mean AWS deployments and big data, as in Hunk, or our relationships with partners that software deep, like the Cloudera, the Hortonworks, and everybody else. So the agenda, very briefly for the meeting, or for the session rather. So we'll tackle two crucial concepts in Splunk deployments: disaster recovery and high availability. So disaster recovery is just a high-level definition. It's the recovery of your services in the event of a disaster, and we'll get to the definitions of those in a second. And HA is essentially defined as maintaining an acceptable level of service continuously. It's under infrastructure duress or anything of that nature. And for AHA, we've split the actual concept into specific facets of the operation. So data collection, indexing, and then search. So we'll talk about each one of those processes in isolation, and then we'll combine them all together. And then we'll finish up with the top takeaways. So disaster recovery is, the way I define it is just a set of processes that ensures that that you can recover Splunk servers after a disaster. Just basic foundation definition here. And the way you do that, it's essentially a two-step process. First, you back up your data, and then second, you restore. It's just classic disaster recovery. So a couple of words about backing up, right? So you need to make sure that you back up in a medium that is at least as resilient as your source, right? So you don't want to back up in a medium that is less, or rather more prone to failures, right? So for instance, you would want to back up in tape, because those things are, have proven, historically to be very resilient, right? And then you probably want to look at, do you want to do local backups or you want to do remote backups? That's probably your number one factor in deciding, what failure or what disaster are you protecting against, right? So, for instance, a local backup will not protect you from the casual cable tripping or the casual fire that happens in your data center, right? A remote backup would definitely help you against that, right? And each of them comes with associated costs and headaches, right? And then two, step number two is restore market problems. So the second step is restoration. Thank you. So restoration, in fact, backup is really worthless without being able to restore. You don't want to back up and then not be able to restore. So you want to, somewhere in the process of backing up and restoring, you want to make sure that this process actually works. You don't want to get a false sense of security that, hey, I'm backed up. I do differential backups every day or every week, and not being able to restore is just completely worthless, right? So in Splunk specifically, there are two major sets of assets that you need to back up. One is configurations, and then the other one is data. The cool thing about Splunk is that most, if not all, of our assets are in files. So you treat every particular backup as just a regular backup of any other software. You're just backing up files, right? And for good measure, for configurations, remember, configurations will always reside under etc, so you can have etc apps, etc users, etc system, right? So you just take a snapshot of all of that every so often, whatever your required policy is. And data typically resides either under Splunk Home or on a custom-defined path, right? Like a volume path that you may set in your, depending on how your storage is configured. Right? There are that's fine. So the backing up process is extremely simple. Like I said, it applies the same with one more caveat to. So it applies to the config files, just like any other backing up of files that you may have in your other, enterprise software. Just copying files. Essentially, you're not doing anything magic. It's not like copying Windows register or anything of that nature. You're just copying files, right? The only caveat is when you back up your data, right? And before we get to how do you back up your data, I just want to briefly stop and talk a little bit about our data lifecycle, or bucket lifecycle. So you guys know when data comes into Splunk, we have a whole indexing pipeline that it goes through, and then it ends up ultimately in a container, also referred to as a hot bucket. That's just a path in your Splunk Home or your volume for data that is currently writable to, right? After a certain number of thresholds is reached, so either by date, so basically either by time, size, or data not being written to the hot bucket, the bucket then rolls into what we call a warm state. So from hot goes to warm, and when that actually happens, the warm bucket is not writable anymore. So data comes in, goes to the hot bucket. When the hot bucket rolls to warm, you cannot write data to it anymore. And then after a certain number of thresholds has been reached, such as either you're hitting up against your volume, or you have too many warm buckets, or you have you've reached your retention policy on date and time, that warm bucket then rolls over to cold. There is, technically speaking, there is zero difference between warm and cold, with the exception of cold being able to reside outside of the path of hot and warm. So cold buckets can reside on a different volume. Hot and warm need to be on the same path, on the same volume, basically. And then, after another set of threshold has been passed, typically by space, cold gets rolled over to frozen. The default action for Splunk to roll over to frozen is you would just delete buckets, but you can, we allow you to hook onto that process so that you can ship that bucket over to some other external storage if you want. So you can tell us a path where to drop those buckets on, or maybe you can call a script that does something to those buckets, and then we delete them from our registry. There is another process that you can revive frozen data back into the system. That's called thawing the buckets. And then there's a thaw directory where you drop the frozen buckets in, and then Splunk D will actually go in and then regenerate the indexes and do everything else that follows, right? The reason I mentioned this is that when you back up your data, there is a couple caveats here. So you can safely back up warm and cold buckets without a problem. Those are, we call them closed buckets. We don't write to those buckets anymore. So again, it's just a collection of files. You can just copy them wholesale. Hot buckets are a bit tricky because we write to those constantly as data comes in. Data coming in can be unpredictable, so you don't want to take a copy of your hot bucket and end up being in a non-consistent state. So you can't really back up your hot buckets unless you're using a snapshot-aware file system like ESS or ZFS, so that you can take a snapshot and then just copy it over. The other option is you can roll the bucket. You can manually roll the bucket to warm, effectively making it read-only, and then you can back that thing up, right? There are performance issues there that you're going to have to be aware of. When you have too many buckets or too many warm buckets, depending on your configuration settings, you might be prematurely aging data out, or just the fact that now Splunk has to keep track of a whole bunch of small warm buckets, introduces a search penalty. So it all depends on what your requirements are here, right? And I'm going to talk about those next. So restoration is pretty simple. So from your backup location, you just move those back into the new Splunk instance. The only caveat here is that there are some configurations that have host-specific attributes, like for instance Splunk secret keys or the bind password for an LDAP authentication mechanism that you may have, or even like inputs.conf where you have the actual host name. Right? So for those 2 or 3 configuration files, before you restore them, you just have to change them appropriately. So if the new instance is the actual same old instance with the same name, you're good to go. But if you're restoring to a completely new instance, then you have to be aware of those changes. Right. Restoration of the data is pretty much the same, exactly the same way. You just, from your backup location, you just copy them over to the new Splunk instance. So we do not recommend restoring or doing partial restores. So if an index has been corrupted for a reason or another, you just do a full restore instead of a partial restore. Right? And again, the beauty of this whole thing is that we deal with files. Right? You're just moving files. That's all you If you have a clustered environment, things tend to be a little trickier. In clustering, obviously, we replicate the data, right? And so backing up everything wholesale, obviously, you're going to have to pay 3 times the cost or 2 times the cost, whatever your application factor is, right? So it all depends on what you want to do. So you can go wholesale. You can basically back up every single indexer that you have. Or option 2, which is the preferred option for me at least, is you identify a copy of a bucket on each indexer, on each clustered indexer, and then you back those buckets only. And we make it easy for you to actually detect that. So non-clustered buckets, so all buckets will start with either a DB or an RB. And they'll have strings like the newest, the oldest time, and local IDs, like bucket ID within a particular index. If you are in a clustered environment, we also append the GUID of the system at the end of the bucket name. And if this is the original bucket of indexer 1, when it gets replicated over to indexer 2, we preserve newest, oldest, local ID, and GUID, but we change DB to RB. So you can have a script that says, okay, back everything up, or back all the buckets and start with DB underscore. And then you are guaranteed not to copy or not to back up replicated buckets.
So the buckets are identical except for the files.
Correct. Yeah. Provided obviously that the cluster is in a valid state, right? Valid and complete state. Yeah, that is the only issue. Yeah.
Now, when you restore them, would the buckets be replicated again, or?
Yes. It depends. It depends on what you actually restore, right? So if you're restoring one indexer, let's say, right, and the RB buckets actually exist on another indexer, right? The cluster master knows what to do, right? Because says, okay, so I need 3 copies of this bucket. All the indexers will report with a bucket list, right? Say, okay, I have 2 buckets here and 1 bucket there, so I'm good to go.
But if it's the entire cluster?
If it's the entire cluster, they will get replicated.
Oh, they will be
If you have the same configuration as brought across again for your cluster, then it will just start up.
Actually, we're going to talk about cluster master after this, right? But the idea is that the cluster master will try to honor the replication factor and search factor for you, right? So when you tell it, hey, I need 3 copies of each bucket, right? It will go out there and then search for that bucket, name, and if it's not there, it will start the remedial process, right?
So, quick question. Since the buckets are identical, I'm guessing that replication happens after the warm stage. Is it the hot stage you're still writing in the bucket?
It's,
you don't have
so we're going to see that in maybe like 10 slides or so. Yeah. So to put restore together, so you bring up a new Splunk instance, you move with the configurations. Right? If it's the same instance, right, where you have the same name, you can just move it wholesale. If it's different, then you're going to have to change those couple of inputs.conf, authorize.conf, maybe your Splunk secret key, change them respectively, and then move the data and the indexes. Again, dealing with files, there's only a few caveats, like I said. There isn't much to it. A couple of things to think about. Obviously, anytime you deal with disaster recovery, and especially before you actually try to implement the disaster recovery process, make sure you answer these questions. Make sure or at least you discuss these things internally. So, such as, how does my disaster recovery process affect the recovery time, and what kind of loads can I tolerate? Right? So, for instance, do you want to go and purchase a very expensive snapshot aware file system so that you can back up or safely back up all your hot buckets, or are you okay if if your hot bucket gets lost in case of a disaster? Right? And And if you're not okay, then you're going to have to think about what is the complexity and what is the cost of that system. So depending on what your requirements are, make sure you choose the right disaster recovery plan. Most customers don't actually do this to be frank. Most customers will say, well, I don't know what my RTO and RPO is. I'll just need to back things up. And there is no, like, what is your recovery point? Right? What is your recovery time objective for that? Yeah.
So between my crash and when I recover, I'm not indexing data, presumably. So how good is Splunk going to be at picking up where it left off when I bring things back online?
Correct. That's a good question. If you're using universal forwarders, we guarantee, and especially if you're using clustering, we guarantee that we'll pick up the data where it was left off.
So the forwarders will hang out. They'll be, oh god, there's nowhere to send this to.
Correct.
So maybe you lose your hot buckets, but you don't lose anything that hasn't even been.
There's, of course, time factor in it. So, for example, it took you 2 months to build up your new instance to recover to.
Yeah.
Well, your universal forwarders, yeah, they flag where it left off.
Yeah.
But if those loads are old,
there's not so much data in there.
Yeah, I mean, if it takes you 2 months to recover, you have other problems.
Yeah.
You have bigger issues.
that's a bad example.
But if you have a good idea that it depends on the
But on that vein though, there is that's a very good point. On that vein though, there are other methods of input that's Splunk accepts, such as networking inputs or scripted inputs, right? If you have networking inputs, and those they tend to be the most fragile ones, because they just shoot data over TCP or UDP, and especially if it's UDP, UDP is just horrible. UDP is just fire, forget, and if there's no listener on the other side, that data is permanently lost. Right? TCP, it's different. There may be some buffering or some flow control that can take place, but if it's UDP, you're totally lost. A couple of other things, maybe not necessarily that important as the data, is the job artifacts. Right? So when you back up search heads, right, there is in addition to configurations, there's other assets that exist there. So one of them is the job artifacts directory. Right? You may have saved searches, or you may have, let's say, TS collect namespaces or things of that nature, where they, like lookup tables, for instance, that they exist solely on the search head. Well, actually, lookup tables will be part of the configurations into the directory, but search artifacts reside on a different path, so you may want to also back that up. Right? It's a dispatch directory, like var dispatch on the search head. Okay. So before I move on to the HA section, any questions so far? The art tends to be pretty straightforward.
Is there a standard recipe that you recommend customers say do A, B, and C, and probably 90% of the
we don't have one that is publicly documented. Our services team does that on a customer case, depending on what their requirements are. But in most cases, what I've seen in the field take place is customers will back up and revision control their configurations, and they will back up only a subset of their data. So remember, if you're ingesting hundreds of gigs of data per day, you're talking about a huge investment in storage. So there's only a subset of, let's say, like very critical indexes that they will definitely back up. And for others, it's very iffy, right? And if you have a clustered environment, you are kind of safe to begin with, right? Unless some major disaster happens. Right? Even if you lose one indexer, you still have 2 others that have the data for some time. But to answer your question, no, I don't. On our documentation side, I don't think we have.
I mean, based on what I've seen, it's fairly straightforward. There will be a set number of locations that you get back up. It's just curious because, like the job artifacts, I had not thought about artifacts. That you mentioned. There might be some other
Sure.
directories that I might.
If I recall, Rachel, I think we have a backup guide, but it's
there's
very
some discussion of it, but it's always. I used to run the questions, and I have less visibility into what's in there now.
Right.
But it's treacherous to write about this sort of thing because you can always. It's not always going to be right for everyone, and it's such a touchy subject. yeah, it takes a lot of analysis of your environment to really know that. But we could always do a better job. And yeah, there's active thoughts about it.
Okay, so moving on to HA. So HA, the way I define it is it's a system design methodology where your system at hand is continuously operational, but also bounded by a set of tolerances, right? Now, I don't want you guys to mistake high availability for complete availability. There's a lot of customers who say, well, I want my thing to be completely available. Well, there's no such thing, right? But there are things that are highly available, measured in number of nines, but there's no system out there that's completely available. Just want to make that clear thing up front, right? So the way we're going to tackle HA is into three fronts. One is data collection, two is searching, and then three is image. Right? I mean, ultimately, they all work together to provide you access to the data that you have collected, but we'll tackle each one of those individually. Collection is pretty straightforward. As of version 4, universal forwarders have auto load balancing capability. So in the past, if your target receivers, basically if your indexers were unreachable, your data was never collected. So if there was a network failure to one of the indexers, or one of the indexers was down for whatever reason, the forwarders had no logic to spread the data over to another set of indexers. So as of version 4, this goes back more than 3 years now. Forwarders have auto load balancing capability, and it's all by default. So technically speaking, you don't really have to do anything. So once you have more than one indexer, on the forwarders, you just list both servers or both receivers, and the forwarding mechanism will do the right thing in case of one of the indexers actually dies. Again, this is just for collection of data. So new data that comes into the forwarder, let's say on the left forward here, we'll always make it on the index. It's baked in by default. Like I said, you don't have to do anything. The setting is actually this one right here. Oops. I don't know if you can see it, but the auto LB is set to true. That's the default setting, so you should be good to go from the onset. So you just have to list all the servers that are your targeted receivers. Okay.
What about data in flight that might be a forwarder?
That's it. That's an excellent question. So we if you care about that, there is a mechanism called indexer acknowledgement that you can have on. It's not owned by default. It introduces some overhead naturally. We ask you that you do that when you enable clustering. But if you care about data in flight, then with the auto LB, you probably want to also enable that too, right? So what's going to happen is if the forwarder, I should have labeled this, so if the data going to the indexer 1 has not been acknowledged for a certain timeout, they'll be sent over to indexer 2. So you'll have the data code.
So yeah, that takes care of data transfer from forwarder to the indexer.
Yeah.
What if, let's say, forwarder 1 is trying to transmit and waiting for acknowledgement, and you have acknowledgement setting, but forwarder 1 goes down. In that case, what about data that is?
Yeah. So if the service on forwarder goes down, then on that level, you as a user need to intervene and do something. So there have been a couple of cases actually where we have customers. You can install. I mean, there are services on Windows, for instance, that will try to bring up the forwarding service automatically in case it dies. But by itself, the forwarder by itself, if it dies, then will require manual intervention.
And that data is kind of processed. Is it stored and
Correct.
forwarded?
No, so the data on the forwarder is actually stored on the file system. The forwarder is tailing the file or reading a whole file from scratch. So it is there. So you don't necessarily lose the data. You just the indexers just don't see it in time as it happens. Right? So it will eventually make it there, right? When you turn back the forwarder on, but if the forwarder service, the executable dies for whatever reason, you're going to have to go in and then just.
So unless there is a physical loss of this.
Correct. Well, right. Correct. Yeah, the forwarders will keep a journal, indicating where in each file they are, and so when they wake back up, not after 2 months, they will know where to go.
Do you still call that the fish bucket?
We call it the fish bucket.
Yeah.
We call that the fish bucket. And that actually, there are some advanced, there are some cool things that you can do with it. For instance, you can have this is not supported, but you can have multiple forwarders installed in a bucket. I'm sorry, installed in an instance, and they can share the fish bucket. Yeah, it is doable. We've done it a couple of times, but again, it's not supported. So if you want to, play around with it, you definitely can. I mean, that opens up a can of worms, because now what do you do when the new forwarder comes back up? So you're going to have to transfer the fish bucket back again. But if you care about data that much, right? So if let's say your entire forwarder folder gets corrupted and you have to install one from scratch, right? Provided you have a backup of that, right? Then you can bring the fish bucket back in so that you can pick up from where you left off.
That's a good point that you just mentioned. Do you normally recommend backing up forwarders? Is there some
typically, most customers don't, but they back up configurations. Right? And in larger customers, the configurations of the forwarders reside on the deployment server anyway, so they just back that instance up instead of each and every forwarder. Okay, so data collection is, like I said, it's baked in. It's very simple. The next one is the searching, and again, I'm treating these facets of the operation independently. So searching is just being able to search your data, right? Not whether you have consistent data or not, just being able to search your data. Right? There are two methods that we provide HA for on the search tier. One is search and pooling, and the other one, the new one introduced with 6.2, is search and clustering. Obviously, the issue with searching is that if you have a hierarchy that typically looks like this, your search head is a single point of failure. Right? So if it dies, you can't access your data. Right? When you, technically speaking, you can go on each and every indexer, but they only. So Splunk is a shared nothing architecture, and each indexer owns or manages just a slice of your data set, so you don't actually see the full picture until you have a search head. And so if your search head dies, then you pretty much stop. So we recognized this problem early on, and we came up with a technology called search head pooling. The goal there was to provide, so AJ was an afterthought actually. The goal there was to provide scalability on the search tier so that you can sustain a larger number of users. And then as a result of that, you also get HA to some degree. So it worked for some definition of work. So I tried. This is what search and pooling looks like. Yeah. So it works. So you have a few search heads, it works. But if you have more than a few, then sharing an interface mount, it's a little. It can get pretty bad sometimes. So the idea there was to have a number of search heads share the configurations via an NFS mount or a Samba mount if you have Windows. The NFS share serves actually three purposes. The search heads will share configurations. They will share job artifacts, and the NFS is also used for scheduler communications. Right? So you also need a load balancer to interface with users. So you give users one single URL and one IP. They hit the load balancer. It drops them to either of the search heads, and then they start working on it as if they were sitting on that search head locally, right? Now, it's important that all search heads have the same configurations normally, right? Because you don't know where the users will land. It's also important that they have the same job artifact. So if you say the search, and from search head A, and then you log into search head B, you want to see those saved results. But more importantly, if you have scheduled searches, you want only one instance of a scheduled search to run at any point in time. Right? If each of the search heads is running its own scheduler and they are configured identically, each scheduler would actually run searches independently. You don't want duplicate runs of your searches, right? Especially if they're populating summary indexes or data model acceleration. Right? So NFS makes sure that the schedulers, the schedulers use NFS to actually guarantee that only one of the schedulers in the pool runs that instance of the search. And it's just a very simple local acquisition on a file, and whichever scheduler acquires a lock on that particular scheduler file, it runs the job. Right? Clearly, there are issues there. NFS is not the most reliant medium out there. The latencies between NFS and search heads tend to be higher than local disk, obviously. So there are still performance issues there. Like doing directory listings or measuring up user quotas and things like that. It tends to be really, really bad on performance. So we kind of gave up on that, and we said, "Wait, to hell with it. We'll just build another one." We call that search head clustering. Right? So we're effectively relying on NFS. It was a quick way to get us to where we are to provide scalability on that tier. But then, as you have more search heads, you start having tremendous contention issues. NFS, while it's good for sharing files, it's not necessarily great for having this quick access to those files. So search head clustering was introduced on version 6.2. It provides horizontal scaling, high availability, no single point of failure, which unlike here, even though you don't have a single point of failure in the search heads, you have a single point of failure on the NFS mount and the load balancer. The load balancers tend to be pretty reliable, but if your NFS mount or access to it actually is not there, your whole cluster or your whole pool in this case is unavailable. Right. So with search head clustering, again, the main benefit obviously is that it doesn't rely on NFS. The way it works is it's pretty similar, but we use, instead of using NFS to actually share everything that we shared previously, right? We use a protocol, right? We use a protocol between all search heads to share configurations and job artifacts. Right? We also introduce a new concept called a deployer instance, which it ensures that all the search heads in this cluster have identical initial configurations. So think of it as your quote-unquote deployment server for your search head. So the deployer pushes the initial configurations to all your search heads in the cluster, and then subsequent changes are replicated automatically via the same protocol.
The job artifacts are distributed across the search heads?
They are. The search head cluster also introduces a new concept called the captain, which is it's a special role that orchestrates the job scheduling and the artifact job scheduling and artifact replication across all the vendors.
So is it true that no matter which search head you go to, use load balancer, any changes you make for the job artifact will go to the captain?
Well, so the way it works is actually pretty it's pretty complex, but high level is this, right? So you bootstrap your whole switcher cluster. The deployer pushes out the initial configurations, and then so you start with fresh, baseline configurations that are identical. All the subsequent changes that happen are, there's an internal replication mechanism that takes those changes and makes sure that they are existing in each and every member. So it's an internal process that all the searches communicate internally with, via a special protocol. The job scheduling, though, it's a bit different. So previously in the pool, the scheduler was running on each and every member. In a searcher cluster, the job scheduler is disabled on all instances but the captain. Right? So now the captain now makes sure that only a single instance of the scheduled search actually runs, and then it designates which instance to run that search. Right? So there is actually, in searcher pooling, there was no notion of search load whatsoever. So whichever search had acquired the lock on that scheduled search file first, that was the winning search, and that will actually run the search. In this case, the captain looks at the number of jobs that each server or each searcher is running, and then it designates. So it makes a load-aware decision. Right? After the search has finished, it produces a whole bunch of artifacts. Obviously, a copy of those get persisted locally on the search head that ran the search, and then they get also then replicated depending on your configuration settings, 2 ways or 3 ways across the other members. And the captain also, obviously the captain orchestrates all of that. Now, if you happen to land, so let's say you run a search, let's say a scheduled search runs, it gets copied 2 ways, you end up, you come back the next day, you log in, you land on search at 5, the artifacts are not there because they just happen not to be replicated there. There's a transparent proxy mechanism that we have in place that the searcher now knows, hey, look, I need a copy of these artifacts. We'll do a transparent proxy. We'll proxy those artifacts over to your search head, and then we'll make sure that that search head has a copy locally moving forward. We do these nice things that we make the experiences as seamless as possible. Okay. So the way you deploy a search head, again, I like a search head pool, which was a couple of lines worth of configurations. Search head clustering is a bit more complex. So first of all, they need to be on the same version, and they need to be in a high-speed network. Actually, we're still running some performance testing. We don't have the numbers of what the latency should be yet, but if you have a local data center, you should be pretty good to go. Obviously, more storage is required than standalone searches because we replicate the artifacts 2 or 3 ways, and it's only available on Linux or Solaris. Obviously, you need a load balancer. That's not a change from search and pooling. You just need a deployer in addition to the load balancer. You just need one small VM. Actually, if you have a master node or a deployment server that is not handling a lot of clients, it can serve as a deployer instance. Clearly, select your replication factor according to your HA requirements. And the way you do it is you deploy. You can do a deployer first. There's a secret key that you have to enter, and then you initialize each instance. You point it to the deployer, and then just pick one to be the captain. And then from that point forward, it's all automatic. There are cases. So there's I don't have it here, but there's a minimum requirement for 3 search heads. So in search head pooling, you needed 2 as a minimum. In search head clustering, you need at least 3. Right? The protocol that we deploy needs to have a majority surviving partition for it to actually keep working. So if you have 2, one dies, the other one has no clue whether there was a network partition or it is actually dead, right? So if you have 3 and 1 dies, 2 is the majority, and they can stay left in the captain, right?
Trying to prevent there being 2 captains.
Correct, yeah. So you don't want to end up in a split brain situation where you have half of your instances not knowing what the other half is. So, you can go, so 3 and forward is 3, right? More than 3 is fine, right? Less than 3. But technically speaking, you can make it work with 2. It actually will work with 2, but you have 0 protection. If 1 dies, then you're done. Yep.
Is this a proprietary quorum algorithm or is it something more standard?
For the orchestration, no, we just use one of the consensus. It's just a Paxos Raft implementation that we did. Yeah, that's a classic consensus switching algorithm. Obviously, it's a custom implementation of it here, but that's the typical consensus switching algorithm.
It works.
It's fine. It's proven it works. It's good. So indexing clustering or indexer clustering. This is where we provide HA functionality for the indexer tier only. And so now slowly you start seeing the picture coming together. Index replication was a feature that was introduced with version 5. It has matured tremendously since. Back then, we introduced the notion of a cluster, which was a set of peers that replicate each other's buckets. So they cross-pollinate each other with buckets. It provides all these abilities like availability, fidelity, affinity, recoverability, all of that sort of stuff, all the cool stuff. Obviously, there are trade-offs here, right? Clearly, you're giving up storage and a slightly increased processing load for all this protection that you get, right? So, so we guarantee that in case of a failure, there's always a receiver. In case of a failure, there's always data will always be there in high fidelity. In case of a failure, the data will be there available for search, provided there is no failure on the search tier. And with later versions, 6.1 and yeah, I think it was 6.1, we introduced things like site awareness and search affinity. I'll tackle those in a second. Right. So a couple components. Okay. All right, that's not cool.
I work here. Escape out of the
yeah, hold on a second. Okay, here you go. So a couple components on the cluster. So you have this master node, which orchestrates everything that occurs in the cluster, including remedial activities, replication as it happens, and it also informs the search head where to find the searchable data. And it also helps with configuring all the search peers. Right? You have this notion of a peer node, which is nothing else but an indexer. You need to have a search head, so you cannot search a indexer cluster without a search head, right? And you need forwarders with auto balancing and indexer acknowledgement if you want to have all the data fidelity, site awareness, and high availability guaranteed. Right? A typical cluster looks like this. Very simple. Great job on the docs team. Actually, they have pretty good material out there. So you have a cluster master, as you can see up top on the left. You have a search head. You have a whole bunch of nodes, 3 peer nodes shown here, and a few forwarders with load balancing on. And if you look at the data paths or the information flow paths, you have the green is actually the load balance data that is going across all the indexers. The light blue is the replication data. So as the data comes into each peer, we persist the copy locally and then we persist the copy locally, we send one to the next node, then we send the acknowledgement back to the forward so that we know that at least you have one persistence. And then the search head and the master node exchange messages with each other for making sure that the search heads are actually searching the peers that have searchable data. Right? We also introduced this concept called replication factor. It's essentially a configuration knob that we allow users to express their intention on how many copies of the data to have. We ship by default with a replication factor of 3. And in this case, a cluster can tolerate, so in this specific case, we can tolerate a RF-1 failures. Right? So if you have 3 copies of the data, right, you can take down 2 or up to 2 nodes, and you still have access to the data. Right. So
what role does the master node play? Like it covered all search and predictions, peer node as well as forwarders.
Great question. So the peer nodes, in a non-clustered environment, the peer nodes do not talk to each other. The master node is the one that orchestrates all the replication. So it tells, let's say, the left peer here to say, hey, for this bucket, I want you to make a copy on this peer and on that peer. And it also tells the search head which peers to search, right? Which peers have the data for a specific search, right? It also then, in case of a failure, it tells the peers where to resend the data to so that the cluster becomes, valid or complete. So it orchestrates pretty much everything. So it's a master. So it knows where where each bucket is located and its state, whether it's binary or not. Right? We'll get to the state in a second. Right? There's also another factor called search factor. Right? So when we get the data in, what we do in Splunk is we persist the raw data in a file. We compress that. We call it the journal file, or journal.gz file. And then we also build a whole index structure right next to it. Right? All the TSIDX files, all the flow filters, and everything else. When you say, I want to replicate my data, we replicate the buckets, but not replicate the index structure right next to it. When you say, I want to make a bucket searchable, and I want to replicate that, indicated by the search factor here, we replicate the whole bucket wholesale of the data and the index structure right next to it. So depending on your requirements, right, you can have requirements such as I want to have a copy of my data, but I don't care if it's searchable or not. Right? But other customers may have requirements like I want all my data searchable all the time, right? And for that, obviously a searchable bucket requires more storage because there is obviously the whole index structure right next to the journal file. So we offer these 2 parameters that you can tweak and tune according to your requirements. Right? So if you just care about the data, just increase your replication factor. If you care about access to the data or have really quick search to the data, then you have to do so with the search factor.
How much space saving are we talking about?
So rule of thumb goes like this. I'm just going to take a number right now. So let's say for 100 gig raw data, uncompressed, right? This results on average, right? There are cases where these numbers don't apply, but on average, it becomes about 50 gigs worth of buckets. And the 50 gigs it's something like 15 gigs will be compressed raw, and then about 35 gigs will be index files. Right. So compression actually works much better than this, but again, rule of thumb, right? Compression tends to be about 1 to 10 or 1 to 11. So you're looking at, the difference is here, right? So 15 to 35, right? So if you do replication factor of 1 or 2, you're just replicating this only, right? If you're saying search factor, you're replicating all of this. Yeah, it's a substantial chunk. Yeah.
So if I have a high replication factor, low search factor, and I lose my indexes and filters and everything, will the cluster automatically reload that?
Correct. Yeah. So when you specify SF equals to 1 or SF equals to 2, the cluster master will make sure that the cluster state becomes valid or complete. And by valid means that you have one copy of the data that you're searching.
Question.
Yeah.
When we enable search factor, does that only take up space, or we also end up indexing that raw data again?
No, it's the whole. So
that thing is just shipped.
It just shipped over. Yeah. So when you say RF equals to 3, we send 3 copies of this. When you say SF equals to 3, we send 3 copies of that.
The reason I was asking was to see if there was a CPU of it, because now we index that data again.
Right. Well, so to his point, if you lose, so let's say you have a situation of RF equals 3 and then SF equals 1, right? And so you have this. You have 2 copies that are just raw data, right? And then you have 1 copy that is searchable, right? So you have 3 copies total, but 1 of them is searchable, right? So if this peer happens to die, right, or the peer that hosts that bucket dies, the cluster master will say, "Whoops, I don't have SF equals 1." So what's going to happen is, oh, I don't have SF1, I have RF2 now, right? So you will bring up another peer or tell another peer to either make a copy of this, right? So this will become a copy, and then one of these copies will become green, will become searchable. And the moment it becomes searchable, then here you're actually indexing. It's actually there's actually substantially less load than you're indexing raw data, because the compressed raw here has a lot of hints on what to actually index. So it will take some time. It could take a bucket of 10 gigs. It might take, I don't know, maybe like 20 minutes or so, roughly. Yeah.
If you reduce the search factor on an existing environment, does it reclaim storage?
To the best of my knowledge right now, I don't think we do that.
It's only for new buckets.
Yeah, it's only new buckets. Yeah. So the way cluster indexing actually works is data comes in, the originating peer will, so as the data comes into one peer, that peer becomes what we call the originating peer of the cluster data. It will then ship a copy to one of the receiving peers. And the destination of that, so the receiving peer is governed by the master. Right? So the master tells each peer, hey, here's your destination. And if you have 2 or 3, here are your destinations. Right? So like I said earlier, initially before clustering, peers did not communicate. They still do not communicate with each other unless they're told so by the master. Right? So the master is the one that actually coordinates all the interactions between the peers and all the remedial activities that happen in case of a failure. The master also keeps track of which peers have searchable data, right? So in this case, for instance, somewhere in its registry, it will say that this peer, let's say, I don't know, peer 1 here, or peer A, if it hosts, this set of data, right? It knows that, for this particular bucket, right? Actually, this is the wrong. So this would be something like this. So this would be one peer here. Peer A. Sorry about that. Peer B. Peer C. So it will keep somewhere in its registry that peer A has a searchable copy of that bucket. Right? And so when a search actually initiates or gets dispatched from the search head, it gets to know where to send that search to. Right? And it also then ensures, like I said earlier, it ensures that there's always a number of copies of searchable data is governed by SF. So yeah, it tends to get pretty hairy when you discuss indexing, cluster indexing. Cluster searching is a bit more complex than pure searching. Obviously, here there's got to be a mechanism that the search head consults. So the searcher does not know, in the cluster environment, does not know which peers have, what searchable, whether they have replicated or searchable data. So it needs to consult the cluster master first for the list of peers before it dispatches a search. And it keeps a cache of that. It doesn't actually do that all the time, right? But every time a search gets dispatched, the list of available peers with searchable data gets populated by the cluster master. Now, one thing to note here is that only one replicated bucket is primary, and that is a searchable bucket for that, or that is a searchable copy for that particular bucket. Right? So you can have, if you have something like RF equals 3 and then SF equals 2, right? Clearly you're going to have 2 greens which are searchable, and then 1 red that is just replicated. But only one of these greens will be the primary. Right? So like, let's say this guy. Right? So this will be the only one serving searches. Right? And when that dies, the cluster master will change primacy to the other one and then make a copy somewhere else.
This brings up a very interesting question. Is when distributing the search to all the peers, it's conceivable that master cannot know a priori which peers actually have data corresponding to the search.
Well, there are cases where that may not be. So there are cases where the cluster is actually in. Let's put it this way. So if a failure has occurred, right? So let's say, I'll give you an example. So let's say the cluster master actually fails, right? Then what's going to happen is the search head will use the last known set of peers as a set of peers to dispatch all the searches to, right? But the actual list of buckets, a list of indexes, and whether those buckets are searchable or not, right, is always present in the cluster master. Right? So if you say something like index equals a, source side foobar, the searcher will consult the master and say, hey, which indexers are responsible for indexers A buckets, right? And okay, here's a list of peers, right? I'll just go out there and then run the search. Right? Does that answer your question?
Right. I mean, the search itself is kind of trying to filter it.
Right. So okay, I got your point. So right. So the cluster master will just give a hint to the search head, or to the search process rather, that hey, these are the peers where you're going to find searchable copies for this index. Now, we do filtering of buckets based on time range, anyways. But the cluster master will not tell the search process, here's a list of all the buckets. Right? We'll just tell it, here's a list of peers that are responsible for this index. Right? So the filtering of buckets on a time basis, will happen regardless. Right? And the process for that is way more complex than this. Okay.
Just want to let you know it's after 9 o'clock.
Okay.
I don't know how much you have.
I've got 3-ish slides. 3 or 4. Right. So I'll just go real quick. Yeah, up to 3. So in 6.1 we introduced multi-site clustering. The goal here was to improve disaster recovery. The idea was that pre-6.1, all the peers were to be located in one site, so there was no notion of a site. In 6.1, we introduced the notion of a site. You don't have to have them in different sites. You can have them within the same data center if you want, in different racks or different, floors or whatever. But there is a notion of a site that you can configure for each and every peer and bucket, right? And with it, we also introduced the notion of search affinity. Right? So if you have remote sites and you have a search head, the cluster master will instruct only the peers that are closer to the search head to respond to the search, right? So if you have a cluster with, let's say, 5 indexers on site A and 5 indexers on site B, the search head will actually go across all of them, right? But only the ones that are closer to you will respond. Okay? So sending searches out is not a big deal. Getting the responses back is where you actually incur, that's the bottleneck in the process, right? So all the peers will get the search because you don't know whether there may be a failure in the next second or not. So we send it out anyways, and then whichever peers are local, that's the only one. That's the only set that actually responds. Okay. You can read more about this in docs. This can get pretty convoluted, but the idea here is that for each node, so when you configure each node, you also assign a site to it. Right? So in addition to having RF and SF, you also have this notion of the site. You say peer A on site 1 is on site 1. It's got this RF and that SF. And then on site 2, you might want to have different SF or different RF, depending on what your HA requirements are, right? Or HA and DR requirements are.
Question for you about RF. How
Yep.
does RF work in a multi-site scenario? You'll have, say,
Right.
we have RF 3, we have.
Right. Okay. Bullet point number 2. Right. So it works. The replication works pretty much the same, with the exception that there is the site awareness, where you configure. Let's say you configure on server.com. You configure how many sites you have, how many copies you want to have. That's a replication. Then how many copies you want to have from the original. And then it actually does the right thing where, so if something fails, we will try. So if a node on site 1 fails, we will try to make it up using. So we make up the data using the local indexers first before we reach across the site, right? And bucket fixing activities, remedial activities, they respect site boundaries. So we'll try to be as local as possible. And if we're not, obviously we'll have to go cross-site. The same thing for search affinity, right? If your search head resides on site 1, the results will be provided by site 1 indexers whenever possible. And obviously the goal here is to have, rather the assumption rather is to have each site contain a searchable copy of the data, right? If you don't have searchable copies, then there isn't much that we can do.
And a forwarder can only forward the indexes in one site.
Well, you can have the forwarders go crazy if you want. There's nothing, this is just one kind of configuration. But you can have forwarders spray across.
Very different photos.
Right. Yeah.
Forwarders also site aware?
No. But you can have the forwarders spray the data anywhere you want.
Yeah.
Right. So
Cross-site as well.
what's that? Hold on. One at a time. So our question was, are the forwarders site aware? No, they're not. So the forwarders will send only to a list of servers, whether they are in a single site or on all sites. Yep.
And the cross-site replication, is that compressed or?
Yes, that is. Yeah, all the replication is actually compressed even within a single site.
Yeah, that's right.
Yeah, we compress it. Right. So to put it all together, so to build a highly available architecture, so there's one search head actually missing here, a minimum of 3. My bad. It should have one there. It's not highly available now. So on the search tier, use searcher clustering. On the indexer tier, obviously use indexer, native indexer clustering. And then on the forwarding layer, make sure you have auto LB and optionally with indexer acknowledgement. Right? What if you do these? Then you're going to need two ancillary instances. One is a deployer that governs obviously the orchestration of the switching cluster, and then a master that governs the indexer replication as well as the searching. Okay, so top takeaways. Really quickly to back up and restore, you have to look at configuration files and index data. Right? Those are extremely easy. This file-based backing up and restoration. No rocket science there. The only caveat there is configurations that are specific to the host and the hot buckets, right, that you're going to have to be aware of. Right? For HA, just a quick recap: auto LB, indexer acknowledgement, searching, reuse clustering, and then indexing and user next replication. And don't use UDP. Yeah. So use a forwarder whenever you can. It's pretty reliable.
You don't cover it here, but on the subject of UDP, at least in some environments, some folks are using UDP broadcast to a heavy forwarder node, and then you use your heavy forwarder node as a forwarder up to your index.
Yeah. So the recommendation there, actually, in many customers, we heavily persuade them not to use UDP at all. In some cases, there's no right. In some cases, there isn't much we can do, but there are there are many customers now with newer devices that support TCP. So the best you can do, right? If you don't have a forwarder, then use TCP. UDP is just horrible. Or use it, but don't ask for much, right? Because I mean, at that point, you're like, okay, it's just a network, right? You may also end up in situations like this. Remember, UDP has no flow control or error control. You may get a burst of UDP that the heavy forwarder may not be able to sustain. It will drop packets. UDP has no clue. It will just drop. If the buffer is full, it will drop it, right?
You like that, David? You should have put an app on it.
Right. Yeah. That's right. But yeah, that's and then if you have other issues with TCP, like network is unreachable, you have a routing problem, whatever. Right, then a universal forward is the next best thing. So universal forward is the ideal thing. If you can't get that, then go to TCP, and if you can't get to that, then it's UDP. Yeah.
Your HA mechanism for the master node?
No, not yet, but I'm not supposed to say.
No,
not yet. not yet. So the master. So don't be too concerned with the master node, right? So the master node does not keep any state whatsoever. The whole cluster state is kept in the indexers. So you can bring up a master node with an identical name or identical IP.
So if it falls over, you just build a new one.
Yeah, just build. Yeah, and then you get as long as you don't have subsequent failures, you're good to go. Right, so just bring up another one, and all the indexers, when they communicate next to the master node, they will send their current state, and you're fine.
What happens during the period that the master node is not available? What is the impact? Is it searches are not?
No, searches are run. The search head will use the last known good configuration, if you will. The indexers will continue operating properly. If there is one failure, whatever failure, either on the searcher cluster tier or in the indexer cluster tier, then you're done. Because there is nothing else out there that can actually govern the removal of it.
But in that case, we're talking about 2 or 3.
Correct.
Master is down.
Yeah, some customers, what they do nowadays for those specific critical environments, they just have because remember, cluster master is very, very minimal requirement machine, right? So they just have
cold standby,
like just a cold standby.
You have to behind a bit.
Yeah, and it's pretty simple. It's cool.
So maybe to wait at the same time with it. So like what about scenario when you can find a stake, huge amount of data, what it uses. So I understand it, like there is no way actually to remove this data. There is way to kind of hide and not to have this data participate in search, but there is no way kind of to save space. Is it correct?
So let me recap. So you have an indexer with a lot of data, you're saying?
No, I was saying that I did by mistake huge amount of data, but I would like to remove it and not to pretty much not to use indexes too much.
Okay.
Space.
Okay. So you want to. So in other words, you want to delete data.
Yes.
Right. Yeah. Data deletion is something that we handle. Normally, so you just have to get the cluster maintenance node and then just clean that index.
So when I was searching this question, the answer was that there is no actual way to do this.
Well,
what I was told that the
You use the
expectation was
delete command. You're not deleting the data. Is that what you're asking about?
apparently yes. You can delete it and it will not participate in the search. However, it will take space in the search.
That's correct.
yeah, that correct.
Yes,
That-
there's
that
no
is-
way around that.
That is a delete command. Right? That is so when you say index equals foo type delete, right? What we do is we're going to mark the buckets, actually all the data in those buckets deleted, and
But you realize you could, by mistake, you could just add which
Yes,
data
that is
which is
true.
useless.
You can clean the index,
Right, we
but you
can-
can't do that surgically. You can only clean out an entire index and actually delete the data from this, or you can use delete and keep the index in one piece and still be able to access the other data in it.
Well, can I export from those buckets into CSV and then remove the stuff I want and then read? Oh, this is really labor.
Yeah, it'd be painful.
You can do it, but it's very
Yeah.
Exactly, but
But yeah,
Clustering
there's
approach.
there's not. We
Yes.
have been hoping to offer a surgical delete option for a very long time, and we just haven't.
well, so no, there are actually even some cases where in cluster. So remember when I said that the warm buckets and the cold buckets are read only? I kind of lied. So when you say delete, right? So when you say index equals foo, source type equals var, pipe delete, for the time range that bucket, or rather for the time range that you're scoping that search on, right, you may correspond to a cold bucket, for instance, right? And the way we handle deletes internally, it's actually a list of all the deletes, all the deleted events in that particular bucket. Right? So what we do is we go into that bucket and then we insert the deleted file, which contains pointers to the events that we delete. Right? So propagation of those deletes across the cluster tends to be very, very tricky, right? And so it's one of the things that Rachel said that when you say delete, fine, you're marking that section of your data unsearchable or unreturned by the search, but we can't just go in and say, okay, now from this journal file, remove a chunk that corresponds to your search, and then go back to the index and remove it. It doesn't work.
This is why we recommend things like having a test index,
Right.
and making sure you
Right.
know what you're getting,
If I
and
know,
having multiple indexes if possible.
if I know that I don't want the contents of an entire bucket, can I delete that bucket?
We probably have to actually stop.
Yeah.
Because pretty much, and another aspect, you may have situation when all the time you just want to really delete some old data.
Yeah.
And if you not actually delete it, it means your index will grow.
But remember that the indexes, you can define retention policies for the indexes, right?
Okay, and then
And then it goes two ways. It goes either by time or by size.
Okay.
You can say I want to keep index equals foo for 90 days. I don't care how much data I have, I just want to have 90 days. Or you can have index foo cannot grow more than 500 gigs per index.
and ultimately will go to another index, and then you could
Yep. And then as those thresholds are met, we're going to roll over buckets. It's a bucket by bucket basis.
and then you could
Before that happens, though, there are scenarios where you can prevent that from happening. Like she says, you can have multiple indexes. Careful with what data you bring in. You can have thresholds of like if this IP sees this much data in this period of time, cut it off. So we have one system that happens to be very noisy once in a while, and when it's noisy, it's insanely noisy, and we don't want that data in Splunk because it's all garbage at the moment. So we set it to where if that IP comes in at us with more than 1 gigabyte in an 8-hour window, shut it off, and it stops. So it receives its 8 gig and then stops all incoming.
Because of this problem, we try to offer a lot of different ways to strategize around it. It is a very complicated problem when you have big setup
Cool.
like that.
All right.
Thank you very much. I'm sorry I went so late. I hope
All right, you
everybody
guys.
learned a lot. And if you're interested in getting copies of these presentations, actually this one is available on conf.splunk.com.
Correct.
2014.
Just post links to those in this
Yeah,
one?
yeah. And then I'll get the other one from you because yours is consumerized. And I'll post a link.
And also, I don't know that YouTube channel move to like replay this.
Yeah, yeah.
I didn't see it.
It's in the meetup.
It's in the meetup.
It's in the comments for the meetup for this particular meeting. But I'll send it all out again. I can email all of you. Thank you. And if you have trash, there's trash up here.
Yeah.
And then there's also a recycling bin back there.
Oh, I will send you guys your email. I'll send it to you.
Yeah, she was thinking about other things by customers.
Yeah, yeah.
Partners.
I'm not sure if she wants partners. She definitely wants customers. But I'll connect you guys.
Have some customers.
No problem.
I already
I'll connect you guys.
reloaded
You
the
have my
two.
email address, so
Yeah, I feel like this one.
Thank you.
Oh, cool.
If I haven't before you guys contact me, reminding me.
All right. Thank you very much.
Thanks for coming up.
Rachel, do I need to?
Yeah.
Restrictions on it. Or
Yeah.
like data inputs. So like, okay.
Well, and these things are getting better. Right? Over time, I mean, we're trying to improve a whole bunch.
It's me on
It's one of those things. It's saturation of data. Yeah, for small data. It's come a long way.